Flexible memory depth is crucial to signal analysis performance. The 7000 series oscilloscope offers up to 500 million points of memory for your signal analysis needs. Let's look at 3 different ways you can configure the memory to get the most out of your signal analysis. First, let's use all 500 million points to capture a continuous 50 millisecond wave at 10 gigasamples per second. So here we have one channel active. We're looking at, we have 10 gigasamples per second, and we're using the full 500 million points of memory depth available on the 7000 series. Here we have 2 milliseconds per division. So let's see what we do. So we capture this RF pulse from our device here. And then we can stop it. We can see that we go out a little bit. We can see we have 5 milliseconds per division and 10 divisions. We have 50 milliseconds of data at a full 10 gigasamples. So that really allows us to see this entire RF pulse from this garage door remote here. So we can really look closely at that. And then, of course, we can zoom in and we can really go in and look at all the detail because we have 20x oversampling on all those pieces. So we can go ahead and zoom all the way in, down to nanosecond range. It's pulsing on and off. And we can see that with more than 20x oversampling on each signal while still capturing an entire 50 millisecond pulse sequence. So it's a great way to use the high sampling capability of the 7000 with the deep memory together to really be able to analyze full signal. A second way to configure the deep memory on the 7000 is to debug signals like this in context. Here, we still have the RF pulse on channel 1, but are looking at a lower duty cycle, higher speed pulse. We're having an issue, so let's dig in and see if we can investigate the cause. We want to see this signal in context with other signals, so we've added a couple other analog channels and 8 digital channels as well. This still gives us the ability to have 5x oversampling on all our signals and 125 million points of memory on the analog channels. Here we can trigger the pulse. Now let's capture it. Now let's scale down, zoom in to 500 nanoseconds per division. And we can really see that pulse, single pulse, in the context of all the other pulses and signals that are occurring. Now we can identify the activity. We can even identify some other signals, like channel 2 in blue and D4 down at the bottom, that appear to be related to this pulse activity and the glitch in the middle of this pulse. So this mode really allows us to see the same full 50 milliseconds of time with 5x oversampling on all our channels, but capture the signal in context and use the memory in a more flexible way to get all the information we need. A third way to capture even longer data sequences on this type of modulation is to use the full memory out to a full 1 second, but combine this with the peak acquisition mode. So this is a longer data sequence from our transmitter, but it's still transmitting at the same 390 megahertz carrier. At this range, the scope is set to 500 megasamples per second, but with the peak detector, we can still accurately capture all of these pulses. This even makes it possible to zoom in and use the math function to decode the pulse modulation. Here we can turn on the absolute value math function. We can rescale that till we can clearly see the bits, and then we can pull this data off of the oscilloscope separately to really get the underlying data from the demodulated pulse activity. So this is a great way to configure the memory to get long data sequences of certain types of modulation out to a full second and still see signals up to 500 megahertz.